And some more AP review. Right now we're doing 2005 Form B, BC question 3. So this is BC only. So the Taylor series about x equals 0 for a certain function f converges to f of x for all x in the interval of convergence. The nth derivative of f at x equals 0 is given by, and then we have the nth derivative of f at x equals 0, and this whole monstrous mess that you can read on your own. Cool. We're also given that the graph of f has a horizontal tangent line at x equals 0. Now, what we can translate from that and what's worth us noting, they don't tell us, but we need to be able to translate that that means f prime of 0 equals 0, right? And that's going to matter. So that's a fact that we weren't explicitly given, but we need to be able to infer from the information that was provided to us, right? So although we were not explicitly told that f prime of 0 is 0, when they say that f has a horizontal tangent line at x equals 0, that's what they're saying. And they also give us f of 0 equals 6. Cool. So part A, determine whether f has a relative maximum, minimum, or neither at x equals 0, and justify your answer. Okay, so this is that second derivative test, right? They are 100% asking you to do the second derivative test, right? And keep in mind that what the second derivative test says is that if f prime of 0 equals 0, which, by the way, it totally is, right? Then the sign of f double prime of 0 tells us if we have a max, a min, or something inconclusive, which if it's inconclusive, that's not actually the same as neither, so it's usually either max or min. So if f double prime of 0 is positive, then the graph is concave up at 0, so level, this means level, horizontal tangent line, and concave up, that would be a min. If f double prime of 0 is less than 0, then we would get a concave down, which would make this a max, right? So again, that's 100% what they're asking. So knowing that, let's go ahead and find f double prime of 0. So we already know the first part, f prime of 0 is 0. So for part A, we know f prime of 0 equals 0, right? Because the horizontal tangent line, right, at 0. And then f double prime of 0 is what happens if I plug n is 2 in to this formula, right? So that would be a negative 1 to the third, right, n plus 1, and then a 2 plus 1 factorial, so 3 factorial, over a 5 to the second, and then a 1 squared, right? So this comes out to be a negative number, right? Because if you look, this is a negative 1, and then everybody else is a positive number. So you have a negative 1 times a positive 6, so there's a negative 6. You have a 25 times a 1. So since this is less than 0, we've got this situation, concave down, and level is a max. So by the second derivative test, it's a max, right? And so the information you need to show is that this thing is, the first derivative at 0 is 0, and that the second derivative at 0 is negative, and then you're allowed to conclude that it's a max. Cool. And that's really all you need. You just need this piece of information. If you were able to do this in your head, great, nobody cares. Cool, so your answer is max. Your reason are these two things combined. Part B, write the third degree Taylor polynomial about x equals 0. Cool. So, it would be worth keeping the fact that I just found that negative 6/25. So, okay, so for part B, right, p sub 3 of x is going to be f of 0, right, plus f prime of 0 over 1 factorial, which is just a 1, times an x minus 0 to the first, plus f double prime of 0 over a 2 factorial, times an x minus 0 to the second, right, plus f triple prime of 0 over 3 factorial times an x cubed, right? So that's what my polynomial is going to look like. So I'll int that over so you can see it. So the trick then is I need to find these numbers. Well, this was given as a 6. This was given inadvertently, right, as a 0. This guy we just found to be a negative 6/25, right? We just found in part A, right? And if you didn't remember that from part A, that's okay. You could do the work again. And this guy I'm going to have to find, right? So I really need to find f triple prime of 0, right? And I'm going to find that by using this formula for n is 3. So that would be a negative 1 to the fourth, so that'll just be positive. It'll be a 4 factorial over a 5 to the third times a, let's see, it's a 3, right? So 2 quantity squared. Okay, so my third derivative should be a 24 on top of a 125 times a 4. I would probably cancel the 4 with the 24 and get a 6 over 125. So this is a 6 over 125. That's what this chunk is right here. So now, so this guy, right? This guy is a 6 over 125. Cool. Okay, so now that I know those values, my job is to write out p sub 3, right? So if I kind of partition this off a little bit. So my p sub 3 of x is going to be my 6. That was easy. And then this linear term goes away. So if you want to write plus 0x, you can, but if you just want to say, hey, that doesn't exist, it's gone, that's also fine, right? And then I need this number, the negative 6 over 25 divided by 2. So that's a negative 3/25 x squared, right? And then I need this 6 over 125 divided by 6, which is just going to be a 1 over 125, right? The 6 would cancel, and that's an x cubed. So again, if you want to write the linear term, you can, even though it's a 0, like you can write it as a 0x, but what you're probably going to see this as is a 6 minus a 3/25 x squared plus a 1 over 125th, sorry, 1/125th, I'm very hard to say, x cubed, right? So this is what you're likely to see. Notice that it does coincidentally happen that there are 3 terms in this, but that's not because of the 3. The 3 is because it goes up to x cubed. There would have been 4 terms if there had been a non-zero value for the linear term, but it was 0. So there's my p sub 3. I should double check that they didn't ask me to do anything with it. They did not. They asked me to write the 3rd-degree Taylor polynomial, and that was it. Lastly, part C. Part C is going to ask me, find the radius of convergence for the Taylor series for f about x equals 0. Show the work that leads to your answer. So remember that when we do radius of convergence, right? So whenever you hear that phrase, radius of convergence, they're pretty much always talking ratio test, right? So the ratio test is the limit as n approaches infinity of a sub n plus 1 over a sub n, right? So in this situation, right, the nth term, right? So the nth term of a Taylor series is the nth derivative at 0 over n factorial times x to the n. And the nth plus 1 term then, right, the nth plus 1 term would be f to the n plus 1th derivative, right, of 0 over n plus 1 quantity factorial over times an x to the n plus 1. So it would be this thing, the red thing on top of the blue thing, right? And again, I didn't write limit because I wasn't really intending to go this route, but look, I did it, so here we are. So this is what I'm going to need to simplify. Now, what makes this slightly more complicated is my nth derivative of f terms are this ugly monstrosity. So the nth one is easy. I'm just going to copy what's here right here. The n plus 1 is going to require a little bit more work. So this is definitely a bit of a crazy ratio. So this ratio is going to look like the limit as n approaches infinity. So I'm going to go ahead and do the red one as n plus 1. I'm going to do that in red. So this f, the nth plus 1th derivative of f at f of 0, of f at 0, is going to be this formula that we were originally given, but with an n plus 1 plugged in for n. So what we're going to get is a negative 1 to the n plus 1 plus 1, which is n plus 2, times an n plus 1 plus 1 factorial, which is n plus 2 factorial, over a 5 to the n plus 1, an n minus 1 quantity squared, times an x to the n plus 1, because that's this piece, right, all over. So this whole thing also divided by an n plus 1 factorial. Cool, that's good times. All right, so we'll clean that up in a sec. And then on the bottom of that, right, I have this thing, right, which is going to be this blue thing, times an x to the n over an, and actually, if you want to make your life slightly easier, you could put the n plus 1 factorial here, because then it doesn't quite make you have the fractions in your fractions that you didn't want, and you could, likewise, you could have said, hey, I feel a lot more comfortable putting this n factorial under that. It's the same thing, and it might feel more comfortable. So if you did it that way, the nice thing about doing that, just to fix this a little because it makes life slightly less ugly, is you could make this look like this. And now it's just a single layer of fraction within a fraction, and it's just a hair less ugly. Again, still pretty ugly. So so this is going to be that formula just recopied, right? Negative 1 to the n plus 1 times an n plus 1 factorial over a 5 to the n times an n. This shouldn't be an n minus 1. Sorry, this should be an n squared. My bad. Just spotted that it was wrong, right? Because in here I'm plugging in n plus 1 minus 1. So this is just an n squared. My bad. Mea culpa. Minus 1 quantity squared. X to the n over an n factorial. Yikes. Okay, cool. So this is where I'm going to start, right, at this point, and I'm going to flip things over and cancel. The good news is that everybody has a matching partner. So this negative 1 to the n plus 2 is going to go on top of the negative 1 to the n plus 1, and so on. So I'm going to erase this top thing. And now that we've used that, I'm going to give myself the full use of the board because this is a monstrosity. Okay, so this whole thing is going to be the limit as n approaches infinity of, okay, so here's the deal. Anybody in red stays on the floor they're on, right? So the negative 1 is going to stay, to the n plus 2 is going to stay here. The n plus 2 quantity factorial and the x to the n plus 1 is going to stay on this floor, right? And similarly, the 5 to the n plus 1, the n squared, and the n plus 1 factorial are all going to stay on the same floor they're on, which they're on the bottom. But anybody in the blue part of the fraction is going to flip floors because I'm dividing by a fraction, so I multiply by the reciprocal. So it's not an accident that this negative 1 to the n plus 1 ends up on the bottom floor and is right below the negative 1 to the n plus 2. I have an n plus 1 factorial here, right? I have an x to the n, cool. I have a 5 to the n on the top now because he was on the bottom of the denominator. I have an n minus 1 quantity squared, and I have an n factorial. Great. Okay, so now I'm going to clean up this disgusting monstrosity. Again, the AP is not giving you a ton of credit for the actual cleaning up work. They're just expecting that you're going to be able to do it. So let's clean up each one of these individually. This guy nets to a negative 1 on the top, which isn't really going to matter in the grand scheme of things because it's inside an absolute value, right? These guys, n plus 2 factorial means starting with n plus 2 and then n plus 1 and then n and then all the way down. That means that this is just going to net an n plus 2 on the top because n plus 2 factorial is an n plus 2 times an n plus 1 factorial, like all the numbers down. So these guys cancel and I just get an n plus 2. The x to the n plus 1 over x to the n is going to net just an x on the top. These guys are going to net a 5 on the bottom, right? So this is going to be a 1/5 because the 5 to the n plus 1 is on the bottom. We'll talk about these guys in a sec, but essentially these guys, we'll call them an n squared minus 2n plus 1 on top of an n squared. We'll deal with that in a sec. And then these guys are going to cancel the same way the other factorial did. They're going to net an n plus 1 on the bottom. Cool. So now let's clean this up a little. Seems to me that if I move all my n nonsense to the front, right, so I'm not actually going to worry all that much about the negative 1, but we can talk about it in a sec. So it seems to me like I have an n plus 2 times, and honestly, you could have left it as an n minus 1 quantity squared if you want. It doesn't really matter. If you had chosen to leave this as an n minus 1 quantity squared, I promise it won't make a difference, and I'll show you in a sec. And then an n plus 1 times an n squared, right? And then what seems to be left is this negative 1, which again won't really matter much, and a 1/5 times x. Cool. All of that is supposed to be less than 1 in the ratio test. So here's the cool thing that happens. These guys are the only guys that still have a limit on them because these don't have n's anymore. Well, this top is an n cubed plus a bunch of stuff. And the bottom is an n cubed plus a bunch of stuff. Like if you clean it up, you get an n cubed on the top with a coefficient of 1 and an n cubed on the bottom with a coefficient of 1. What that means is that as n approaches infinity, since the degrees are the same and the leading coefficients are 1, you get a 1 over a 1. So these guys net a 1. So this is a 1 times the absolute value. Because of the absolute value, I don't care about the negative. The absolute value of a 1/5 x is less than 1. So I multiply by 5, and I get the absolute value of x is less than 5, which means the radius of convergence is 5. So what this looks like, because it's x minus 0 on the inside, is essentially you've got a 0, and you're 5 units away on either side. Now the question mark, because they didn't say radius, they said, oh, they did say radius, the radius of convergence is 5. So the radius of convergence is 5. If they had said interval, I would have to check both endpoints, right? I'd have to check 5 and negative 5, but they didn't, they said radius, so I'm done.